Okay, we're starting part 2 of dividing polynomials. We're going to be looking at the factor theorem and the remainder theorem. So one of the things that we're going to explore is how the value of P of A is related to the remainder of your polynomial divided by x minus a, or the factor of that. So I'm going to have you guys hit pause, and I want you to calculate this guy over here by synthetic division, and then I want you to evaluate P at -5. So if you guys could hit pause and see what you come up with. Okay, so let's take this first one and synthetically divide. So we're going to switch the sign, and then we're going to put our coefficients, 1, 10, 29, 24. So remember, draw your arrow, we multiply, and then add. We multiply, add, multiply, add. So keep in mind, this is our remainder, okay? So we would get 1x squared plus 5x plus 4 out of x plus 5. So let's evaluate now P at -5. So let's do -5 cubed plus 10 times -5 squared plus 29 times -5 plus 24. So something like that, totally type it all in your calculator. Easy peasy way to do that. But if you type all that in, you'll notice that you also get an answer of 4. So conclusion is, when you do synthetic division, that remainder is the same answer that you get if you evaluate it. Okay, so when you evaluate a function at that solution at -5, that is the same as that remainder that you would have gotten by synthetic division. So kind of a cool little connection there. So this leads us to two theorems. The remainder theorem, that states that if a polynomial p of x is divided by a factor or a binomial x minus a, the remainder is going to be the same as evaluating that polynomial at that value of a. So just like in our Explore lesson there, this p of x, if we took this guy and we divided it by that, so if we divide it by x plus 5, that is the same as evaluating that at the opposite of that, so -5. Gets you the same answer either way. And this should have been highlighted. The second topic is the factor theorem, and it states that the expression, or your binomial, your x minus a, that will actually be a factor of the polynomial if when you evaluate that, you get a remainder of 0. So anytime you get a remainder of 0, that tells you that that binomial is a factor of the entire polynomial. Okay, and that's kind of where we're heading over the next couple days with these things. We're going to be able to put all these little pieces together with synthetic division and this remainder and factor theorem. We're going to put them together to actually solve bigger problems. So right now it's just background and learning all these little steps, but eventually they all get put together. So let's use the remainder theorem and the factor theorem, and we're going to tell if this binomial is a factor of that whole polynomial. And if it is, we'll write it in factored form. So this is like that x minus a that it's referring to up there in the remainder theorem and the factor theorem. So I'm going to take the solution to that. So remember, we go over here and we solve that. That's like the a part. I'm going to take that and I'm going to do my synthetic division. I'm going to drop this down. Multiply, add. Multiply, add. Multiply, add. If you get a remainder of 0, that's actually a good thing. That means that x minus 6 is one of the factors of this whole giant polynomial. Okay, so that tells me that that's a factor. This guy here is the other factor. So I will do 1x cubed minus 2x squared plus 4x plus 1. If I times that by x minus 6, I'm going to get what I started with. That's what this remainder theorem and factor theorem are talking about. Okay, let's see what happens in our second example here. So if I have this binomial, I would do synthetic division with -3. And it looks like we're skipping some powers here, so don't forget to put in zeros when we skip our powers. We drop down the first number, we multiply, and we add. We multiply, we add. We multiply, we add. I don't know about you guys, but this just makes me happy to do synthetic division. It's so much fun. And we multiply, and we add. Notice this guy here. Did we get a remainder of 0? No. So that means this is not a factor. So x plus 3 is not a factor of that whole polynomial. Okay, whereas over here, when we get a remainder of 0, it is a factor. Okay, so I'm going to have you try these two in your notebook. See if any of them are factors. And then the other one there is having you also evaluate. So give those two a try.